All right, so this chapter is really easy to be successful with if you use the calculator. Okay, so I'm going to use that a lot to model, just like I did in the notes. So first off, as soon as we see this symbol right here, we know it's a square root function. You can abbreviate. All right, now I don't need you to fill all this out. Okay, no need for that, but or at least the middle part. Okay, that's what I meant to say. Sorry, I meant to circle just the middle part. It's a good idea to write down your points, but you don't need to fill this out. Okay, you don't need to show the work because I want you to use the calculator. So what you're going to do is you're going to go to y equals and clear it out if there's anything in there. There's not, but that's what you would do. And you're just going to enter second square root, and it says x. Now, you've got to be careful on the calculator not to just write plus 2. Because if you do, that's going to be underneath the radical. Okay? So you need to make sure you hit the x and then use the arrow to come out from underneath the radical. And then write plus 2. Okay? If you want to get a picture of the graph, you can by hitting graph. I just say go right to second table and get your points. All right? And you're going to put these points on the paper and then graph them. Now notice, if we try to go past 0, we talked about this before, you cannot take the square root of a negative number. Okay? So I'm actually going to write some of these down just to remind us. Okay, so I'm going to put -2, -1, 0, 1, 2, 3. Okay? So when we do this, -2 obviously gives us an error. Square root of 0 is 0, plus 2 is 2. Square root of 1 is 1, plus 3, plus 2 is 3. And actually, I'm not going to do 2 and 3 because that doesn't always make sense because it's just a decimal and we're not going to graph a decimal. So what I'm going to do is I'm going to go here and go past this and look for the next whole number. Okay, and that's going to be 4 and 4, and then 9, 5. So 4, 4, and 9, 5. And that will give me some good points to graph. So I'm going to put 0, 2 right there, 1, 3, 4, 4, and 9, 5. And I'm just going to sketch it like so. And it's not, I didn't hit every dot. It's not perfect, but you get the gist of it. All right? Try to be more specific on paper. It's hard to do on this. Now, my domain, remember, domain is how far left does it go? Well, how far left is it going? 0. And it's hitting 0. It's going on forever to the right. How low does it go? Be careful with this. How low is 2? Okay, so it's going 2 up forever. Because the lowest point was 0, 2. It doesn't go below that. All right? Number 2, you see a little 2 here. That means it's a quadratic. Okay, so we're going to put that in the calculator. We're going to go to y equals. We're going to clear out whatever's in there. And we're going to type in x right there. And then squared, we're just going to hit the square button. Now, on some calculators, you have to hit an arrow to go down. This one's fine, but sometimes it will stay, older calculators, it will stay up with the 2 and you have to arrow down, but this one you don't. So you just do plus 2x minus 3. Remember, use the gray minus key for subtraction. Okay? And then we're just going to go to the table again. Now you can see these numbers get really big really fast. So I want to look at the numbers that I can actually put on the graph. Even 12 is going to be too high. So I'm going to go between there and there. Okay, so -4, 5, -3, 0. So -4, 5, -3, 0. It was -2, -3. -1, -4, 0, -3, 1, 0, and now you're starting to see it repeat. And I can keep going, it'd be 2, 5. All right? And I'm just going to plot those points. So -4, 5. -4 up here to 5 is going to be right there. -3, 0 is going to be on the axis. -2, -3 is going to be down here. -1, -4, right there. Then 0, -3, right there. It's starting to match now. 1, 0 on the axis, 2, 5. It's always going to be a mirror image. And this point right here is special. That's my vertex. It's my lowest point. Now, how far left and right does it go? It goes left and right forever. How low does it go? Well, it goes to that vertex, the lowest point. So it hits -4 on the bottom and goes up to infinity forever. And we use a bracket on the -4 because it hits -4. Hit pause if you need to. All right, on this next one, I'm going to clear it out. Go to y equals and clear it out. I'm going to put 2, and I'm going to put to the power. I'm going to use that little caret key, and then type up here x plus 3. Now remember, on some of these calculators, you might need to put this in parentheses. And then to get down here, I arrow over and do -4. And I'm just going to go to my table. Again, if you want to hit graph to see what it looks like, go for it. All right. So if you look what's happening here, it's C on the right, on the Y, it's getting closer and closer to -4. Now this calculator is wrong. Eventually you'll have an error, but it cannot hit -4. That is an error in the calculator. It does not hit -4. So be careful of that. All right? So we're just going to put some points on here. -2, -2. -1, 0. 0, 4. And 112, which is actually going to be off. And I'm going to stop here because it's off the screen. So remember, with this number right here, this tells you where the fence is, the electric fence. It can't go past -4. All right? So we actually already know our range. We know our range, how low it goes, is -4, but it never hits it, so we use parentheses. And it's going to go up. We saw it go up towards infinity. So I'm going to plot my points. -2, -2. -1, 0. 0, 4. And 112 is going to be kind of off the chart. So it's going to come down like this. And remember, it's just going to ride along this line and never hit. So how far left is it going? Forever. How far right is it going? Forever. Gradually, but it's going to keep going right. Oh, and I forgot to write up here that this is an exponential growth problem. Because over time going this way, it's going up. All right, and last one here, in this top part, we have an absolute value. We know that from the absolute value bars. This one's a little tricky. We have to go looking for this one. So we clear out what we got. We're going to go to math, okay, over here to number, and hit enter. And then type in x plus 3. And then to get out of it, we're going to hit right arrow, and then write -6. And there's our v. So I'm going to hit second graph to get my table. It's going to look like that. All right? So I'm going to have some points. I can't, -10, 1 is going to be my furthest one to the left. Put that up the top here. And then -9, 0. I'm going to skip a few. -5, -4. And the very important point, whoops, not what I wanted, is right here. -3, -6. Because then you see it starts to go back up. And it's going to mirror everything. So we're going to have -1, -4, and so forth. And it's just going to start going up the same way. So 0, -3, and we'll stop there. So negative 10, 1, we said was over here. Okay. Negative 9, 0. We skipped to, let's go to that, get that lowest point, negative 3, negative 6 on here. Negative 1, negative 4, and 0, negative 3. And there you're going to have the V that is the absolute value. So how far left and right does it go? Forever left, forever right. How low does it go? That's an important point, negative 6. But this time, it does hit it, and it goes on forever upwards. All right? This part will go quick. Identify the type of function. Well, over time, it's going down in a curve, so that's exponential decay. You can abbreviate. We see the V for value, absolute value. A curve again over time going up, so that is a horrible E, exponential growth. This one's just a straight line, so it's linear. We have a parabola, so that's called quadratic. We can abbreviate. We have linear again. Just happens to be a negative slope this time. Here we have a decay again. Here we have a parabola again. Absolute value again with the V. And finally a new one here. This is that square root. Okay. Moving on. Now, just identifying it from the function, the way it's written. Okay. This one is exponential. But since this number here, the base is less than 1, then it's exponential decay. We see the 2 there. That's a quadratic. We see the absolute value bars. I can write. Here we just have x to the 1, so that's a linear function. That's in mx plus b form, slope-intercept form. Here again, we have an exponential. This number is bigger than 1, so that's going to be exponential growth. That's supposed to be a W in there. Here we have the absolute value bars. Now this one's kind of a tricky one here. Okay, we have an exponent. 0.4 is the same thing as 4/10. That's less than 1, so that's exponential decay. Again, here we have a linear function, just a straight line, mx plus b. Again, we have an exponential, but this is a tricky one. 5/2 is 2.5. So it's not just because it's a fraction that we say decay, it has to be a fraction less than 1. So in this case, it's exponential growth, because 5/2 is bigger than 1. And then this is kind of obvious, this is a square root. All right, now for this one, we have to look for patterns. So on this one, if you look at this, from here to here it's going down by negative 6, subtracting 6, subtracting 6, and so forth. All right? So if it's changing the same plus or minus every time, that's a linear equation. So this one, we try looking first at what's happening here. And that's going to be plus 30. Okay? And then from here to here, we're going up plus 42. And here we're going up plus 54. And here we're going up plus 66. Now that first level does not give us any pattern whatsoever. So we need to go to a second level and see what's happening. So from here to here, we're adding 12. Here to here, we're adding 12. And here to here, we're adding 12. So at this point, when the second level is constant, just like this one was constant, all minus 6, When this one on the second level is positive 12, or just plus the same number or minus the same number, we know we have a quadratic. All right, and then here we have times 2, times 2, times 2. I think 1, 2, 3, yeah, I just didn't draw the line very well. All right, if in that case, we're having exponential. All right. Simplify. Okay, so notice we have a square root out here because there's no number. So we want to look for magic numbers that are perfect squares. So here we are going to use 25 and 6. 25 is a perfect square. Here we're going to use 64 and 2. And here we're going to use 4 and 6. Kind of notice what's we're going here. We're going to have a common radical, hopefully. So remember to multiply by anything on the outside. That's very important. Here we have a minus 1. Okay, so this square root of 25 is going to come out as a 5 times the 2x. And then the radical 6 is staying. And now, with the x cubed, remember we're going to divide. So 3 divided by 2 is 1, so we're going to have another x out here, but one of the x's is going to be stuck inside. All right, now here, that was a play. I need to make sure that was a plus or a minus. Now here, we have the square root of 64. Square root of 64 is 8, so we have plus 8 times x squared. And on the inside, the 2 is going to stay, and this x, don't forget that x up there, don't leave anything behind, is going to be there. And this last one, the square root of 4 is 2, so we're going to have minus 2, all right? Then 5 divided by 2 is 2, which is going to leave 1 inside, along with the 6. Now look what's happening here. On here, we have 10x squared times the square root of 6x. Then we have plus 8x squared, both x squareds, but notice the radical is different, so we cannot combine those. Minus 2x squared, another x squared, along with the 6x, like terms. These two can combine, not the middle one. So 10 minus 2 is 8, so we're left with 8x squared, radical 6x, plus 8x squared, radical 2x. And last but not least, right here, remember this is the same thing as this, depending on how your brain works. Either way, we need to get rid of the 4 first. Okay, so we're going to have the cube root of x plus 4 equals 9, or we have x plus 4 to the 1/3 equals 9. Same thing we're going to do here. The opposite of cube rooting is to cube both sides. All right, so that leaves me, I put my line in the wrong place. It just cancels the radical. So we're left with x plus 4 equals 9 cubed. So 9 times 9 is 81, times 9 is 729. And here, we're going to just take it to the exponent of the reciprocal, 3 over 1, or just 3, which will lead us to the same x plus 4 equals 729. And now we just subtract, and we get 725. And that's it.